In this problem, using the law of sines, we need to show that in a triangle ABC, the ratio of these two tangents, in the numerator we have tangent of b minus c over 2, and in the denominator we have tangent of b plus c over 2, that's equals to b minus c over b plus c. So let's begin from the left hand side. So we have on the left hand side tangent of b minus c divided by 2. Now we know that the tangent is the reciprocal of the cotangent function. So that means the denominator, tangent of b plus c over 2, if we take it to the numerator, that will simply become cotangent of b plus c over 2. Now what we'll do? We will convert the tangent to its equivalent sine and cosine ratio. We know that the tangent function is the ratio of the sine to that of cosine. So we're going to get sine b minus c over 2 divided by cosine of b minus c over 2. Then cotangent can be also converted to the ratio of cosine over sine. So we're going to get cosine of b plus c over 2. And in the denominator we have sine b plus c divided by 2. Now what we'll do? We will multiply the numerator and the denominator with a factor 2. This is done because we know that the numerator is simply a standard formula. So that's actually sine b minus sine c. The difference of the two signs, that gives us the numerator, and the denominator is simply the sum sine b plus sine c. Okay, now let's define the law of sine. If we consider a triangle with vertices given by a, b and c, then this is angle A, the side opposite to angle A, which is BC, we're going to represent it by the letter A in lowercase. Then consider angle B, the side opposite to it will be AC. We're going to represent it by the letter B in lowercase, and the remaining side, AB, which is opposite to that of angle C, we'll represent it by C. So that means the law of sine states that the ratio of sine of the angle A to that of the side opposite to it, so that's A, that will be equals to the ratio of sine of the angle B to that of the side opposite to it, which is B, that will be equals to sine of the angle C to that of the side opposite to it is C. Now this is the law of sines. Now in a case, what we'll do? We will assume that these three ratios are equals to some constant lambda. In doing so, we can now represent sine A as A times lambda. Sine B will be represented as B times lambda, and sine C will then become equivalent to C times lambda. So let's replace all this value here, and this is going to give us a sine B. This will be simply B times lambda minus C times lambda divided by B times lambda plus C times lambda. So we can factor out lambda from both the numerator and the denominator, which leaves us with B minus C over B plus C. So this is the expression on the right hand side, hence proved.